Problems involving work. Cecilia and Aaron work as volunteers at a town's recycling depot. Cecilia can sort a day's accumulation of recyclables in 4 hours, while Aaron requires 6 hours to do the same job. How long would it take them working together to sort the recyclables? We need to use a rational equation to solve this, but let's first think about an incorrect way to think about this. One incorrect approach would be to think that since Aaron and Cecilia are working together, you add up their times and it would take them 10 hours working together. But we know that that's not true, because if they're working together, they should be able to do it much faster than if they were doing it on their own. And another way to think about this would be to think about Cecilia doing about half of the job in about 2 hours, and Aaron doing half of the job in about 3 hours. So working together, it might take them 5 hours, or maybe you could cut that in half, it would be maybe 2.5 hours. And both of these approaches are getting closer to the right idea, but all of these are going to be incorrect. So the best way to think about how to approach this problem is to think about how much work they can get done each hour on their own. So for Cecilia, if Cecilia is working on her own, it takes her 4 hours to do the whole job. That means that each hour she can do 1/4 of the job. And Aaron each hour can do 1/6 of the job. And so if we think about it this way, we can think about it in terms of how long it will take them together. So let's actually look at a little bit of a chart. If we made a chart using the same idea, in our first hour, if Cecilia did 1/4 of the job and Aaron did 1/6 of the job, if you would add those together, you would figure out how much of the total job they've done. So that would be, with like terms, you would say it's 3/12 plus 2/12. So they've done 5/12 of the job in 1 hour. So it's not complete yet. In 2 hours, you would basically multiply each of their rates by 2 to figure out how much work they've done. So Cecilia's done 2 times 1/4 is 1/2, and Aaron's done 1/3 of the job. So now if you're getting common denominators, they've done 5/6 of the job together in 2 hours, so that we can see that we're getting closer. 3 hours, you do a similar idea. 3 times 6 is 3/6, so we now get common denominators. And they've completed 5/4 of the job. So you can see that it's somewhere between 2 and 3 hours. Because here we've done more than the whole job, and here we haven't quite done the whole job. So to figure out exactly how much time it would take, rather than guessing 2 hours or 3 hours, we're going to plug in t for time, meaning that's how many hours it would take, t hours. So this would look like this. 1/4 times t would be t over 4, plus 1/6 times t would be t over 6. And your whole goal when you add these two rates up is to get it to equal exactly 1. Not less than 1, not more than 1. And this idea right here is how we're going to set up our problems involving the work principle. So actually, let's look exactly what the work principle is. The work principle says that each equation, when you're solving them involving people working together, it's going to look like this. And what this equation says is that A represents the amount of time for person A to complete the work alone. In our case, this was the number 4 for Cecilia. For B, this is the amount of time needed for the person B to complete the work alone. In our problem, this was the number 6. And T represents the time needed for them to work together. And 1 means that the job is complete. The reason we use 1 means that it is 100% complete. So now that we understand this work principle, we've actually already set up our equation right here. But let's go and solve the Cecilia and Aaron work problem using our 4 steps. So T represents, we define our variable, time to complete work together. It's their time. And now we use the work principle. we figure out the amount of time needed for Aaron and Cecilia working together using their rates. So for Cecilia, it's time over 4 plus Aaron's rate of work, which is time over 6, and that equals 1, meaning that their job is complete. And again, this equation we first found using this chart right here. So let's go back and solve this rational equation. Now that we've defined our variables and set up our equation, we can solve for our variable. And to do this, we want to clear our fractions. So we'll multiply each side of the equation by the least common multiple. In this case, we'll multiply each side by 12. And when we distribute, we get 3t plus 2t equals 12 when we multiply here. Now when we combine like terms and we isolate the t variable, t is equal to 12 fifths. So exactly how long is 12 fifths? That's the same thing as 2 and 2 fifths. So it takes 2 and 2 fifths hours to complete the job. So just under 2.5 hours. Let's do one more problem together. It takes Fontella 4 hours to put up the paneling in a room, while Omar takes 5 hours to do the same job. How long would it take them working together to panel the room? Again, we define our variable that we're trying to solve. T represents the time working together. And we use our work principle. Again, our work principle, I'm going to put it over here on the side, is always T over A plus T over B equals 1. The rate for the one person plus the rate for the others has to add up and equal 1, because that is when the job is complete. So we say, in this problem, T over 4 for Fontella plus T over 5 for Omar equals 1. And let's see how long it would take them working together. We clear the fraction by multiplying by 20. And when we distribute it, we get 5t plus 4t equals 20. So 9t equals 20. So t equals 20 over 9. So it takes 20 over 9 hours, which, if you think about that as a mixed number, that would be 2 and 2/9 hours. We could try and figure out exactly how many minutes that takes as well, but we'll leave it in hours for now.